Hi folks, welcome back to Physics with Captain Rod. All right folks, I'm making this video here as preparatory for your class period tomorrow. Tomorrow's Thursday, and again, I will not be there tomorrow. I'm going to have, I've got somebody, her name's Joanne, she's going to kind of keep an eye on things and help you out with the lab. I'm going to discuss some things you need to know for the lab, however. So again, I apologize for not being there, and this will be a very rare occurrence in class. But anyway, the first thing that's going to happen is you're going to take a quiz. And I don't want you to panic. That quiz is not a graded quiz per se. It's designed for me to assess how effective the video assignment was at helping to teach you about trigonometry, or to teach you about the vector addition. So what I'm assessing is the assignment, not you. So you're not going to be getting a grade on that. You're going to be given 15 minutes. Please just do the best you can and then hand it in. Then you're gonna go on with the lab. Now there's some background info you have to know for the lab, and I'm going to discuss this right now. So in physics, what we do is we use coordinate systems to track, I like to say track particles. So imagine this coordinate system right here, right? That's fixed, it's not going anywhere. And we're going to use it to describe the location of this car. And I put a little dot here, where what I'm going to call x is the x coordinate basically of the dot of the car. Now, one of the things you have to get used to in physics is we're going to be looking at time-dependent quantities. 99% of the time, or 99 out of every 100 graphs you've probably ever seen, had a y on the vertical and x on the horizontal. Well, in physics, we're going to see a lot of graphs with other things on the vertical and time on the horizontal. In general, the horizontal axis is the independent variable, and the vertical axis is the dependent variable. And so in this example and in your lab, this is going to be what we're going to be keeping track of. Now imagine that the car is just not moving at all, it's just sitting there. Well, if the car is just sitting there, then, and I plotted x against t, and I'm just going to make up some values here. Let's say this is, I don't know, 5 meters. That would be about 15 feet. So we would start plotting this at t equals 0, x is 5 meters. A second later, still 5 meters. A second later, still 5 meters. A second later, still 5 meters. A pretty boring graph. It would look something like this. Now imagine, however, that the car is moving to the right. And it's moving at a speed of 2 meters every second. So the first point now, and let me draw this in, how about green? The first point is still here at t equals 0, the car's at x equals 5 meters. But a second later, it would be at 7 meters. So this next point is maybe up here somewhere. And a second later, 9 meters. And a second later, 11 meters, and so forth. So our second graph is looking something like this. Now, when you talk about, if you look at this, you'll recognize that's going to be a line. And one of the most important quantities here when you're talking about lines is slope. If I pick any 2 points on this line, like here and here, this is referred to as the run. Normally in algebra class, that was a change in x, but here that's going to be a change in t. And then this distance is called the rise. And again, in an algebra class, typically that would be a change in y, but here it's a change in x. So the slope, which is rise over run, is delta x over delta t, and that's called velocity. And there's actually 2 pieces of information there. This car is moving at 2 meters per second, but you notice that the slope is positive, and you notice the positive x-axis points to the right. Well, the car, notice, is moving to the right. Imagine I changed this, and the car was moving 2 meters per second to the left. And I'm going to draw this graph in blue. So maybe it starts out at the same point, but a second later, it would be, let's see, at 3, and a second later at 1, and a second later at minus 1. And that'd actually be down here somewhere. So my graph is not perfect. Humor me, let me just do this, because I just kind of eyeballed this, but this would look something like so. And you'll notice that this now has, pardon me, you'll notice that the slope is negative. Right? It's minus 2 meters per second. So velocity, you'll notice it can be positive or negative, and those have physical interpretations. In our problem here, if our velocity is positive, it means the car is moving to the right. If the velocity is negative, it's moving to the left. So there's two pieces of information there. There's a magnitude, the 2 meters per second, and a direction. That makes velocity a vector quantity. Now, let me go back to our example and imagine for a moment that the person steps on the gas. So now what would happen is, in a moment here, I'm going to redraw some stuff here. Let me get rid of this. Axes. X against time. So now as the car moves to the right, I'm going to use this dot to represent the car. If the person gives it the gas, a second later the dot might move something like this. And a second later, the dot would move further and then further. What we call the delta x's, the change in positions, they would get larger and larger because the car is moving faster and faster. So now our graph would maybe look something like this. Because every time, if I look at a couple points, every time you have a delta t, your delta x needs to get bigger. Delta t, bigger delta x. Delta t, bigger delta x. This graph has a property called concavity. That one is concave up. In this example, the velocity of the car is changing. It's getting bigger and bigger and bigger. So what I'm going to do now is draw another graph. I'm going to shrink this down, give myself a little more room. Down here, we're going to draw another graph, and that graph is going to represent the velocity of the car against time. Now, in this example, maybe the car started from rest. Whether it did or not super important for right now. Let me just assume it did. And then a second later, it's moving at a certain speed, so our velocity has increased. And a second later, the velocity has increased. The car is moving faster and faster. So our velocity graph might look something like this. Now, whether or not it's linear or not is not important for this discussion. Suffice to say, though, that the graph getting bigger means larger velocity or moving faster. As opposed to this graph, what's telling us that the car is moving faster is the slope. See how if I pick 2 points, the slope's changing? Right. Now, if we go back and we take a look over here again and we talk about slope, slope is rise over run. Well, now that's going to be a change in velocity over a change in time, and that's called acceleration. So that's probably enough to give you a reasonable idea now, at least some terminology to talk about the lab. What you're going to be doing in the lab is you're going to take the coordinate system and we're going to replace this with a motion sensor. You're going to want to set up the sensor like this. You'll see these tomorrow. This will be on a table or something. Probably you're going to put like a table here, and you're going to put a motion sensor on the table. And this is going to be hooked to a computer. This is all laid out for you, kind of ready to go. It'll take you a few minutes to kind of set it up. And then instead of the car, we're going to have a person. You're going to do this. So let me grab my favorite physics person here, Timmy. There's Timmy there. I use Timmy a lot in my pictures. Timmy, where are you? There's Timmy there. Giant Timmy. There's Timmy. Now, I say Timmy, this is going to be you folks, a student, physics student, without the basketball. So what you're going to do, and again, you'll see this tomorrow, you're going to set up a sensor. The sensors are green. There's my sensor. Okay, sorry about the crappy picture. And what the sensor is going to do is it's going to send out a sound pulse. You're not going to see it. and the sensor will keep track of you, and it'll generate graphs of position against time and or velocity against time. So that's basically what your lab's going to be about. And the idea is it's going to show you graphs like this, and then you're going to have to figure out how to walk to generate those graphs. That's probably enough on this. That should get you going in the lab. I know this is not in great detail, but that's kind of the idea. Some highlights of the lab here. If you have trouble with your sensor, like if you get really crummy graphs, try swapping the sensor out. Also, there's a button here that goes back and forth between, like, you'll see like a basketball and a person. And I don't know, I don't find any real correlation, but I find sometimes just changing that button from one to the other just makes the thing work better. Another thing you can do, there are some vertical sheets of paper. They're like cardboard. They're in the lab. I'll try to have those set out for you. If you hold one of these right here, nice and vertical, as you walk back and forth, that will help the sensor work better and things like this. Now, when you generate your graphs, if you generate a graph and it's got, you've got a pretty decent looking graph, but it's got some little blips in it, these are no reason to worry about redoing it. All right, just a couple little blips, not a big deal. I can ignore those and look at just the big picture when I take a look at it. Now, what you're going to do for the lab, as far as how you're going to turn it in, this is going to be a little tiny bit of a pain. And again, this should be the last time that I'm not there for the semester, hopefully. You're just going to take a picture of every page of that lab, and I'm going to put a spot for you to upload it. And when you generate the graph on the computer, just take a snapshot with your cell phone. And again, we're going to use Cam Scanner, convert it to a PDF, and you'll have a spot to upload it. The lab itself, I'll give you till next week to make sure that you get everything done. One more thing about the lab, it's got some preliminary questions to it. They're actually entitled preliminary questions. Just skip those and get to where it says procedures and get the lab done. You can go ahead and do the preliminaries outside of class before you hand this thing in today. All right, so that's probably enough to help you out. Hopefully I'll get a chance to stop in and see how you folks are doing, as I won't be actually that far away. I have a meeting commitment that I can't get out of. So anyway, and I'm going to spend today making more videos for you folks and kind of monitoring for questions. So yeah, have a great Thursday.